Assalamualaikum and hello to everyone. In this video lesson, we will continue with Chapter 2, Air Psychometry for our course MEC351 Refrigeration and Air-conditioning. So in this video lesson, we will look at subtopic 2.8 Air-conditioning processes, and we will cover the first two processes, which is the simple heating and also simple cooling. On the right of the screen are the objective for this subtopic. Okay, before we look at the first process, let's ask the question on why do we need to condition air, or why do we have to do air conditioning processes to the atmospheric air. Okay, the answer is to ensure human comfort inside a confined space. Confined space here means whether it may be a room or maybe a building. So when we condition air, we must try to make the air as comfortable as possible for the human beings inside the confined space. We must control the temperature, we must control the humidity, we must control the velocity, and also we must make sure that the air is free of contaminants. Okay, so there are four basic air conditioning processes. So you can see in the video and also in the notes. Simple heating, simple cooling, humidifying and dehumidifying. And these four basic processes, we can combine them. Okay, depending on our application, we may combine four of these processes. Okay, and using the psychometric chart, as we have seen in the last subtopic, we can visualize, or we can illustrate what happens to the air during a air conditioning process, meaning that using the psychometric chart, we can plot and we can see what will happen in terms of the properties. Okay, whether the temperature increase or the temperature decrease, or whether the specific humidity increase or maybe decrease or maybe remain constant. Okay, so we can use the psychometric chart and we can see what will happen for the processes. Okay, next, when we analyze the air conditioning processes, we have to use these three basic equation. Okay, the first two equation is basically the mass balance for dry air and also for vapor. Okay, entering the system must be equal to leaving the system. Okay, for dry air and water vapor. And then we must apply the energy equation, or the SFEE. Okay, so this equation is basically from the SFEE. However, we have neglected the kinetic and also potential energies. Okay, so all of these three equations must be written, okay, when we want to analyze for air conditioning processes. Okay, now for the first process, simple heating. For simple heating, there are two key points. Okay, the first key point is that the specific humidity omega will remain constant. Okay, omega for air entering the system and omega for air leaving the system must be the same. In other words, entering the system state 1, leaving the system state 2, so must be the same. And the second key point is that for relative humidity phi, okay, phi1 entering the system will decrease, meaning that phi1 will be greater than phi2. Okay, so this is two key points for simple heating process. So this is the schematic diagram. Okay, so make sure you can draw the schematic diagram, and this is what happens on the psychometric chart. So the process line will move to the right. Okay, from state 1 heating process to state 2, temperature increase, omega remains constant here, omega 1 equals to omega 2 remains constant, and phi decreases. So phi1 here is greater than phi2. Okay, so that is what happens on a psychometric chart. Okay, so for mass and energy balance, for dry air entering the system must be equal to dry air leaving the system. For water vapor, vapor entering the system must be equals to vapor leaving the system, and we know that omega equals to mv over ma, so we can cross multiply and we can replace m dot v with m dot a omega. Okay, so using this equation, okay, we can substitute m dot v. So since m dot a1 equals to m dot a2, we can cancel and we can get the expression omega 1 equals to omega 2. Okay, so from our energy equation just now, or our SFEE, since heating process, so Q out we can cancel, and since there is no work interaction, there's no W out, there's no W in, so we can cancel both work in and work out equation. So what remains are only this. Okay, then we can rearrange to find the amount of heat added. Okay, the amount of heat added to the air, so we can calculate using this equation. So this unit is either in kilojoule per second or kilowatt, or sometimes can also be in kilojoules per minute. Okay, so this is depending on the m dot. Okay, if depend on the m dot, either kilojoule per second or kilojoule per minute. Okay, so next is the simple cooling. Okay, so for simple cooling, two key points. Okay, two key points. The first key point is for specific humidity. For air entering the system must be the same as air leaving the system. Okay, so same as simple heating just now. Omega is equal. Okay, but for phi, okay, so phi 1 here, simple cooling, phi 1, okay, must be less than phi 2, or in other words, phi 2 is greater than phi 1. Okay, either one lah. Okay, meaning that the phi will increase. Okay, the phi will increase. Because why the phi increase? Because more moisture is added to the air. Okay, sebab kita sejukkan udara. Okay, so lebih banyak kelembapan yang akan masuk dalam udara tu. Okay, so phi 2 is bigger than phi 1. So on the psychometric chart, if we were to plot for state 1, okay, and then plot for state 2 and draw the process line, we can see that the process line will move to the left. Phi will be the same, omega will be the same, and phi will increase. So phi 2 here is greater than phi 1. Okay, temperature will reduce lah, because we simple cooling. Okay, so for mass and energy balance, so dry air entering the system must be the same as dry air leaving the system. For water vapor, same as just now, vapor entering the system must be the same as vapor leaving the system. Okay, one inlet, one exit. Same as just now, we can expand, okay, the equation for m dot v using the equation omega equals to m dot v over m dot a. We can expand, okay, into the following equation. Since dry air is the same, so we can cancel and we can get omega 1 equals to omega 2. For our energy balance from the SFEE, since cooling process, so Q in 0. Since there is no work interaction, work in and work out is also equals to 0. So this is the remaining terms from the SFEE. Same as just now, to find the amount of heat removed, Q out, so we rearrange the equation and we will get this equation here. And the unit in capital letter, kilojoule per second or kilowatt. And depending on the mass flow rate, sometimes will be kilogram per minute. Okay, so 2 units here. Alright, that is for simple cooling. Now we look for the look at the example for simple cooling. So you can pause the video to read and understand the question. Okay, so when we read the question, question, what we have to ask first is, we want to use the equation or we want to use the chart, okay, to find the properties of air. Okay, so first question, equation or chart. So this one we have to look at the pressure. Okay, so if the air pressure is 1 atm or 101.325 kilopascal, we can use the chart. But now the air pressure is 300 kilopascal. So when 300 kilopascal, we cannot use the chart, we must use equation to find the properties of air. Okay, so whatever properties we have to use must come from the equation. Okay, for step 1, like, if possible, please try to draw the schematic diagram for a simple heating process. Okay, so label the diagram properly. Okay, and step 2, we write what is required. Okay, so from the question, okay, ask us to calculate relative humidity at the pipe outlet, meaning phi2. Okay, phi2. So we use the equation. So for phi2, the equation is as follows. And when we look at this equation, we find that there are some values which we have to calculate first. Okay, which are, first is the omega 1. Okay, because why? Because remember, simple heating, omega 1 equals to omega 2. So when we calculate for omega 1, it's the same as omega 2. So we have to know the equation for omega 1. So we write the equation for omega 1 first. And when we look at the equation for omega 1, we have to find PV1 first, the partial pressure for vapor at state 1. So using the value for phi1, okay, phi1 we know 90%. So using the value for phi1 and using the equation for phi, we can substitute the value and count for and calculate for PV1. Okay, so Pg1 here is read from the property table, P saturated at T1. The next item, the question asks us to solve for amount of heat. Okay, so the amount of heat added to the air, okay, in the system. So using the energy balance, but this time the unit must be in kilojoule per kg. So small letter q, okay, small letter q in. So divide by m dot, we get small letter q, and it is simply H2 minus H1. So the enthalpy at state 2 minus the enthalpy at state 1. So we use the equation to find enthalpy. Okay, so H2 and H1. Okay, so next, step 3, we find the properties. So state 1, okay, we have to calculate for omega 1, but before we calculate for omega 1, we have to find PV1. So we calculate PV1 first and then substitute into the equation to calculate for omega 1. And omega 1 here equals to omega 2. Okay, and then for enthalpy at state 1, to calculate the amount of heat added just now, we have to calculate for enthalpy at state 1. So we use the equation, we fill in the values, and we calculate for H1. At state 2, okay, we have to calculate for phi2. So we substitute the values. Okay, so Pg2 here is actually P set at T2. Okay, so we open the table, A4, find the temperature for state 2 and read the saturation pressure for state 2. And then we have to calculate for H2. Okay, and then finally for step 4, we just have to substitute to find the amount of heat added to the air. Okay, so H2 minus H1. Now the second example is for simple cooling. Okay, humid air at 1 atm. So there's a hint there, 1 atm. Okay, so you can pause and read the question. Okay, to understand the question, you can pause the video. Now, like the first example, we have to ask question, you want to use the chart or you want to use the equation? Okay, so from the question just now, we have read that the pressure is now 1 atm. Okay, so when we ask the question, use equation or chart, the fastest way is to use the chart. We can use equation, no problem, but will be longer. Okay, jalan kerja dia akan panjang. So nak mudah, guna chart. Okay, berdasarkan nilai properties yang ada, kita plot dan kita boleh baca properties dia. Dan kemudian tinggal nak masuk equation sahaja. Okay, so for step 1, we draw the schematic diagram. For step 2, okay, what is required? The first one, it wants us to find, or now we are using chart, so it wants us to read from the psychrometric chart the specific humidity. Okay, gunakan chart, baca specific humidity. Dan specific humidity ni ingat dia sama, 1 sama dengan 2. Okay, so tak kisahlah kita baca dekat 1 ataupun kita baca dekat 2, dia akan sama. Okay, the next dia nak suruh kira, ask us to calculate the cooling rate, the amount of heat removed from the air. In units kilojoule per kg, in other words, Q out small letter, Q out kecil. Okay, so gunakan SFEE. Okay, gunakan SFEE, kira untuk Q out kecil, small letter Q. So H1 minus H2. So H1 and H2 values are read from the chart. Alright, easier way. So for step 3, so based on the properties yang ada dalam soalan, we are going to plot the chart and we are going to read whatever properties we require. So for state 1, we have to read omega 1 and H1. For state 2, we have to read H2. Okay, so we plot the chart. So plot for state 1 first. Okay, find the temperature 30 degrees Celsius and draw the property line until it intersects with 60% relative humidity. Label state 1. Okay, and then plot for state 2. Okay, so now state 2, the temperature is at the dew point temperature. Okay, so dew point temperature is the last curve line. Okay, dekat curve garisan melengkung yang paling akhir tu, itu dew point temperature. Okay, so selari dengan state 1 ni, selari dengan state 1 parallel to state 1, we will plot for state 2. Kenapa selari? Sebab ingat, simple cooling, the specific humidity is the same. Okay, omega 1 must be the same as omega 2. So that's why dia selari. And then we draw the process line. Okay, simple cooling. Okay, from here we draw the property line. So first we want to read omega 1, which equals to omega 2. We draw the property line. And then we want to read for H1, we draw the property line. We want to read for H2, we draw the property line. Label H1, H2, omega 1 equals to omega 2. After labeling, we write them down. Okay, what are the properties? Okay, as precise as possible. Omega 1, H1, H2. And then we substitute into the equation, step 4. Okay, so here we can see that omega 2 equals to omega 1, 0.016. When we read from the chart, it is 16. 16. Tapi 16 tu gram. Kita nak kilogram. So kita bahagi dengan 1000. Okay, so Q out equals to H1 minus H2. So baca nilai H1 71 setepat yang mungkin. Baca nilai H2 setepat yang mungkin. Alright, the lines must be parallel to the closest line. Must be straight. Okay, jangan bengkok. Okay, jangan tak lurus. Okay. So once we have read, we can fill in the equation. Okay, so jawapan dia. So this is the end of today's video lesson. Thank you for your attention. For exercises, you can refer to the notes. For questions, you can ask during our discussion session in our class. Thank you.